Okay, I'm Lisa Buckaloo. I'm your pre-calc instructor, and I wanted to make a quick video going over one of the examples that has given students problems and they're asking questions about it. And it's also on the first little exam 1A test. And it has to do with solving systems when we're using that matrix augmentation, especially the larger systems. So I'm going to go ahead and switch over to my notebook so we can go over this problem. This is something that you would find in the homework set that's from section 11.2. It's number 8, but there are other problems also that deal with given an augmented matrix, how that relates back to a system. And then this row reduction or row operation method that we use is sometimes called Gaussian-Jordan elimination. Depends on who you are reading, what text or source we're looking at. Gaussian, Jordan, or sometimes it's just called row reduction. And this is just sort of a shorthand where instead of writing out all the equations and then taking our x terms and eliminating the x by, eliminating the x coefficients, and we just do it on the with the numbers instead of the whole equation. Goodness, I need to practice speaking. So this is instead of having an equation like this, I should say minus z equals -6. The second one would be 7x minus y plus 8z equals -4. Our third equation would be 5x plus 8y plus 1z equals 4. All right, so hopefully you're already kind of getting the hang of taking a big system like this, making sure everything is in standard form where you have all your variables on one side in alphabetical order. Your equal signs all line up, and the only thing you have on the other side of the equals of the equations are the constants. So -6, -4, and 4. That's what these represent. So of course, in our previous algebra classes, if you haven't seen this shorthand method before, we wouldn't go with the matrix. We would just start with here, and we were just kind of taught, well, let's take a 3-variable system and reduce it by eliminating one of the terms so that then we have a 2-variable system. And then once we have 2 variables, then we will eliminate one of those variables and get it down to 1 variable, and then we can solve it for that variable. Once we get a hold of the actual value for one of the variables, we can just kind of substitute it back through our systems that of equations we've created to find the solutions for all 3 values. So for example, if I was just going to take and eliminate x, and we're going to start with the top 2 here. Since I have a 1x over a 7x, if I wanted to eliminate the x values, I would first take the top row, multiply everything on both sides through by -7. So that would be like taking -7 times our top row. And I'm not going to go through the whole thing here. I don't know why I keep writing plus -z. All right, but if I was going to take -7 through all of that, let me do it. -7y, negative would be plus 7z, 7z equals 42. Right, we're taking -7. You can take any equation, multiply a constant through everything, and you have an equivalent equation. So instead of x plus y minus z, I have -7x negative y plus 7z. And then the negatives, of course, make positive 42. So that's my new, that's -7 times row 1. So this is my new row 1. And to it, I'm going to add my other equation, this one right here. Goes right here. So I'm just copying down the original second equation like this. Okay, so there's -7 times the first row, so I can get my x's to combine and cancel with the 7x in the second row. And then when I would add those together, my x's would cancel, which is what I'm after. So I have no x's, and then I would have -7y minus 8y would be -8y. -7 minus 1, pardon me. Then I would have 7 plus 8 would be 15z, and then 42 minus 4 would be 38. Okay, so this would be an example of taking two equations that have 3 variables in them, and then manipulating them a little bit by multiplying one of them And since it has a 1 here, it was easy to just multiply it by the negative of the 1 down here. And then that creates a series of terms where when we combine them, the x terms cancel out. So it's like I have no x's at all. We don't have to write down 0x because of course that's what I want, a smaller system, which is 2 variables instead of 3. So I'm not going to continue with all this because that's what the row operations are designed to kind of skip over and make it a little easier to do all this. But I just wanted to remind you of what it is that we're trying to do. All right, so let me start again. Here is the augmented matrix form that we just had on the other page, or my 3 variable, 3 equation system. And what? That's what I just had. 1, 1, negative 1, second negative 8, 8, 1, and so forth. All right, now what we're being asked to do is the row operations, they'll write the row operation next to the row that they want replaced with the result of this calculation. So that's why there's nothing written next to the top row. So that means we're going to, in our new result, when it says write the new matrix, the top row will be the same. But we're going to make changes to the second row and the third row according to these instructions. Okay, so let me write those next two. So -7 times the top row added to the second row. And then -5 times the top row added to the third row. All right, so these are the two things that I want to do. So I'm going to go ahead and write a kind of running version of my new equation again. So there's nothing written next to the top row, so that means there's going to be no change when I write my new version where I've done these adjustments. Okay, now here's what we're going to do. This says take -7 times everything in row 1 and add it to row 2. Okay, so remember, these are the X columns from what we were doing before. This is exactly the same idea as what I did when I had it all written out. I took -7 times the top equation, which is what this was down here, and then added it to the second equation. Okay, so it's the same thing that we do when we're eliminating the X's. We're just kind of using shorthand where we just write down the coefficients, and we understand that depending on what column these numbers are in, it tells us what type of term it was. So if it's in the middle second column, that was the coefficient for Y and so on. Okay, so here's what we're going to do. We're going to do -7 times row 1. I'm just going to write these results up here. Just, it's kind of a shorthand. You learn to do it in your head, but in the meantime, this is what I'm going to do. -7 times 1 is going to make -7. -7 times 1 is going to make -7. -7 times -1 will make +7. And then -7 times -6 will make 42. So look at that, -7, -7, 7, 42. Look, that looks just like this when we did the adjustment, -7x, -7y, plus 7z, 42. So we're just creating this equation without writing all the x, y, z plus equals and all that stuff. Okay, now what did we do with that? We added this result to what was already in row 2. So that's what this is. So -7 times row 1, that's what these little numbers are here. And it says add it to row 2. So I'm going to take these little numbers and add them to the middle number. So -7 plus 7, that's going to be 0. Okay, I'm going to put that where that was. That was -7 plus 7. That's where we got 0. Now we're going to do the same thing here. We're going to take this -7, we're going to add it. -7 plus -1 will be -8. Do the same thing here. +7 added to +8 will be 15. And then the last one here will take 42 added to -4. 42 plus -4 will be 38. Okay, so I have 0, -8, 15, 38. That's my new row 2 that was arrived at by taking each little pair of coefficients from the first row and the second row and doing this. -7 times the top number added to the bottom number. That's what that means for every one of these. And look what this is, 0, -7, 15, 38. Remember when I was doing this longhand and I finally added the two equations together to eliminate my x's? I got -8y plus 15z equals 38. Negative 8, 15, 38. Negative 8, 15, 38. So this is, again, it's the shorthand for not having to fill up 4 pieces of paper trying to write down all the equations. Okay, so this is an example of where this one came from, and all of these are also the same. Like the 38 came from taking negative 7 times this, which is the 42 added to the negative 4, gives me 38. Okay, so that takes care of the second row. We've done that one. Now we're going to go back through and do the same idea because we want to also eliminate the x's down here. So think of this again. This is like a 1x over a 5x, and we're trying to eliminate the x's. So kind of ignore these that I have written up here. And we're going to, now we're going to try to eliminate, it's like if we had over here a 1x stacked up over a 5x plus whatever else in an equation. Well, to get rid of the x's, we'd take that top row times negative 5, and then when we add them together, the 5's would drop out. So what I'm going to do here is take negative 5 times the row 1 up here, and then add it down here to these numbers. And that should create a 0 here, which is, that's the whole goal, is I'm trying to get the zeros in these 2 spots here, because that's the same thing as eliminating my x's. Okay, so here I'm going to do the same thing. I'm going to write my numbers for negative 5 times the top numbers on the other side. All right, so negative 5 times row 1 is negative 5 for this one. Negative 5 times 1 is another negative 5. Negative 5 times negative 1 makes positive 5. And negative 5 times negative 6 makes positive 30. Okay, so what I'm doing here, I don't know if it helps to do a different color because I know this is getting kind of crammed up here, or if you can even tell. But for, here's my, what I'm going to do now is add them together. I've done this part. I've taken negative 5 and multiplied it times all these numbers. These were the original numbers, 1, 1, negative 1, negative 6. So I've gone through and I've multiplied negative 5 times each of these. Okay, so maybe I'll write those up here so we can make them. Negative 5 times 1 is negative 5. Negative 5 times 1, negative 5. Negative 5 times negative 1, positive 5. Negative 5 times negative 6 is 30. So I just went ahead just to, I don't know if this makes it any easier to understand or not, but this is the negative 5 times row 1 results, kind of closer. I'm going to add these to my bottom row here. It says take those results of adjusting the top rows by negative 5 and then add them to the third row. So I'm going to go column by column and take this new number and add it to the bottom row. So negative 5 plus 5 makes 0. That's what I wanted. I wanted a 0 here. And then for the second column, when you do negative 5 times 1, you get negative 5. Add it to what's already there. Negative 5 plus 8 is 3. And then we'll do it again. Negative 5 times the top row is now going to be positive 5. We're going to take positive 5, add it to the third row. 5 plus 1 is 6. And then on the last one, negative 5 times negative 6 was 30. We're going to add 30 to the third one. 30 plus 4 will be 34. Okay, so this is the result that they asked for when it says perform the matrix row operations. That's these. I've just finished this part. And then write the new matrix. Okay, so the new matrix, the top row is the same. There were no changes here because there were no instructions about anything to make alterations to the top row. So it's, oh gosh, it's hard to see. Sorry. Is that a different color? These were the original values before I started messing around with everything. Okay, so there were no changes to this. The second row, we want a 0 here. This is a way of saying we eliminated our x's from pulling 2 of these together. And then the 0 in the x column for the third row here means that we also eliminated the x's here. So just to clean it up, this is my final answer in terms of just making those adjustments. 38, 0, 3, 6, 34. So this would be, it's not the final answer by any means if we're trying to solve this thing, but it is the result of doing these row operations instead of writing out all of this stuff every time we want to eliminate a variable. So instead of writing out all of this, we kind of did a little cheat sheet and wrote our little numbers up here, but we just went ahead and wrote the new row right out there. Okay, so this is all we are asked to do in number 8, so that would be enough to put in the answer. But the idea was, if we were going to continue to do this, once we have eliminated the x's here, then this gives us a new smaller system right there that just has y's and z's in it. And then we would proceed to do the same thing. Again, on another round down here, we would get zeros here to eliminate the y, and then we could solve for z. But this is just sort of an intermediate step. Okay, I hope that helps. I know that's a lot, but that is what we're trying to do when we are solving with these matrix things. And we are going to speed up at some point and learn how to use our calculators to kind of carry some of these calculations further. But you do need in pre-calculus to know how to do this stuff by hand, because many of you will go on and do other things that require the same manipulations. So, okay, I hope that helps. Number 8 from 11.2, it's also on our first test.